Well, my name is Charles Utermohle, and I'm fortunate here today to discuss how I went through automating InstantAtlas production using the Access Data Manager. So here my goal was trying to summarize the Alaska Behavioral Risk Factor Surveillance System using commercial off-the-shelf software. And as the solution, I went and automated the creation of the InstantAtlas data files using the Access Data Manager in conjunction with SAS Macros and SAS Callable Sudan statistical software. An ancillary benefit of this enterprise was that the Analyst component can also be used to comprise comprehensive data analysis results when XML creation is not needed. The software requirements are the InstantAtlas Access Data Manager. Within SAS, you require the SAS base as well as the SAS Access. And SAS Access is a module that allows you to interface with either Access or Excel. And last, I'm using SAS Callable Sudan for its ease in creating age-adjusted rates, but this potentially could be substituted with SAS Stat. So the process of creating XML data files starts with an inventory of health indicators. Then next we will create database pairs for each geographic system. So for, in my case, Alaska is using 4 geographic systems, and so for each one of them I create a database, one for the crude rates and one to hold the age-adjusted rates. And last, we input the parameters into the table data layout, all within the Access Data Manager to govern analysis. So to conduct this inventory of health indicators, first I put all the information into an Excel spreadsheet. Within the spreadsheet, I've identified my theme, my indicator, and the variable of interest. I've also indicated all of the years of analysis. In this particular case, I shortened it to the last 11 years. And on this, I've identified which survey instrument contained the variable. So starting in 2004, Alaska moved to 2 survey instruments. We have what we call our standard survey, which is our CDC-funded BRFSS, and then we've also added a modified or supplemental survey funded by our Alaska Tobacco Control Program, which is denoted by an M. When variables appear on both the standard and modified survey, I've indicated that with a C. So this sheet allows us to see where or on what survey instruments the variable appears, and then I've created unique data files for time series. On this chart, I'm using a color code of red to indicate when I can only use single year data, and green when it's possible to produce 3-year averages from the information. And because I'm using 3-year averages, I need to have a consistent variable name. So over here under the variable, you can see a lot of indicators with preceded by an X, which indicates that these are my time series variables. Lastly, I wanted to show that in addition to using percentages, we also have a few healthy days indicators in which we're producing mean days for poor physical health, poor mental health, physical activity limitation and days, and also poor sleep. So this is a necessary prerequisite for setting up our analysis protocols. So if you have just single year analysis, you can just use your existing variables, even though the names may change between years. That's not important if you're using just single years. The inventory of health indicators facilitates creating summary variables and data sets when you have to use multi-year averages as a result of varying combination of survey instruments or split frames over time. Within the Access Data Manager, we create a new table called Table Data Layout, and this contains our variables of the theme ID and theme name, which provides our order of themes and labels, a question ID and question names, which provides the sequence, our RISVAR-N, which is the name of our BRFSS variable, a response ID and indicator name, which is our response sequence and label, our meta text, which in this case would be our BRFSS survey question, which custom palette, the color specification you want to indicate for that variable, the RISVAR-T, which is our short name and response categories such as sex, male, and include and exclude. And this enables us to define response categories for the numerator and denominator, such as when we're looking at general health, we can contrast poor, which has a value of 5, versus response categories 1, 2, and 3 without having to create a brand new variable. Next, we're able to identify which age grouping specification we'll be using for age adjustment, the geography and the geography levels. Like I say, in Alaska, we have 4 geographic systems, and the levels range from 6 to 29. Last, we were able to put in the years and the time interval. So you were able to do analysis for either on a single line, if all the variables appear in one data set, you can do all of that analysis on one line. If it's using multiple data sets, each unique data set will result in another line for that variable. And last, we're able to specify the data source and which is the weighting variable. So you're able to use, in the future, we'll be able to assign weights, whether it's based upon adults, children, or households. This schematic shows how we use the take the data from the Access Data Manager. So we have the table data layout feeding information here into our SAS Callable Sudan program for percentages, and then we will have a comparable table data layout _ mean for those few variables which require means. They are drawing upon a common directory which contains all of our BRFS data sets. Because we're computing both age-adjusted and crude rates within each program, the output is being directed either to our database for age-adjusted rates or the database for crude rates. And the information is being stored in table raw data. After we've run through all of the variables, we can then use a series of user-defined queries to proof the data and format it to the specifications required by table data. And last, we can use the create data form within the data manager to create our XML files. So the SAS Natural allows acquiring analysis parameters from the table data layout and the Access Data Manager. It identifies the variable. It identifies the response categories that we want to use in the numerator and the denominator, the year or year range, the geographic variable and number of subdivisions, the computation of regional and statewide values with a breakdown by race, disability, age, or poverty status, for example. And then we're creating both crude and age-adjusted rates. And we're also using the National Center for Health Statistics data quality evaluation, and then also specifying data suppression rules. Within the BRFSS, we typically suppress data when it's based upon fewer than 50 respondents. And last, we can export the data into our table data raw of respective databases for accrued and age-adjusted rates. Here I've selected some of the SAS code. Here we can see we've creating the macro called risk var, and then next we're specifying which variables that we want to be able to access throughout the program. We're identifying the path in which to find the Access Data Manager. In this particular case, we have it on our C drive in a InstantAtlas subdirectory. And we're also using identifying what is going to be our suppression rule for the data. In this particular case, for the BRFSS, we're using 50. If this was YRBS data sets, this would be increased to 100. And lastly, we're using the SAS Access module to import the data from the Access database. And so here you can see we're bringing in the data table. This is our table data layout. We're storing it as data layout, and then we're bringing it in from the database. And here is my convention that I use for identifying my database. I have my geographic system. This one is the Alaska Department of labor market areas. I'm using, this database is summarizing single year data, and I'm using our 2011 BRFSS data set for age adjusted, and at this time I'm using the version 6.61 of the Access Data Manager. This is the core of the procedure, is creating macro variables. What we're doing is we've taking the table data layout variables from the Access database, and we're bringing it into SAS, and we're trying to turn them into macro variables for use in the statistical analysis. So here's some examples. We earlier had discussed the question ID. What this is going to do is read all of the rows within the data, and it's assigning a count. So we're creating an array. We're bringing in our question ID. Here's our risk var n is our BRFSS variable, response ID, the text that goes with the variable. To subdivide the information into response categories, we're using the include and the exclude. We're identifying what age adjustment distribution to use, which geographic systems and the geographic levels, what is the year range, and what is the interval. So if we're using single year, we can specify, we could do all 21 years of the data, saying like 1991 to 2011, and our interval would be 1, or we could specify this as 3-year averages. Next, we are able to identify the unique data source to use with that variable for the particular time frame that has been specified. So the actual analysis here occurs within Sudan. Here we're using the proctis script, and you can see that we've, in this particular case, we have hard-coded here. We're going to use a variable called final weight. We've previously in the program, we've defined our variable of interest into 2 categories. And we're doing an analysis based upon geography. We have in Alaska a 3-race category of white, Alaska, and everybody else, so we adds up to 100%, and then we're giving our year range. And our subgroups are the age group, the geography, the years, and the race, and we specify that. What we're getting back out of this system is we're outputting the sample size, the weighted sample size, the percentage, the confidence interval at the percentage, the standard error at the percent, the strata and the primary sampling unit, and also the design effect. So these data are used both to summarize the data and are also used in the National Center for Health Statistics to evaluate the quality of the information. The value of using Sudan, the script, is just that the addition of just 2 lines, our standard var, which will be our which age grouping variable we're using, and then by applying the standard weights, we're able to output the data after it's been age adjusted. So once the data analysis happens, what we do is we go through a process where we extract the existing data that has already been previously imported into the database in our table, raw data. We append the results of our new analysis, and then we export back out the updated information back into the Access database. So it's an iterative process. As each analysis, we bring in the existing information, append the new analysis results, and export it back out. Once we've gone through the analysis step, the value of using a database is that now we can post-process the information. So we have a sequence of queries that automate the transformation of our raw data into the data layout. And then we have our breakdown categories, in this case race. If we have health goals, when present, they're added as comparisons. We're able to specify the metadata, the data quality indicators, and we can compute the differences from the statewide mean on the spine chart and area profiles. And then finally, the data can be exported as comma-separated values for use by adaptive devices. And lastly, we can do, the XML data sets can be tailored to the specific InstantAtlas templates. So once we've created our XML files, we can go through the InstantAtlas publisher, and then we have the range of templates that we can use the data files to put into our presentations. So the end result is that by using this process, we are able to summarize all 21 years of the BRFSS data. We've organized them into 29 themes comprising 172 health indicator variables, and we've had 4 geographic systems resulting in 48 unique geographic units. So the end result is that we have over 1 million data points for time, geography, and indicator, each for our crude and age-adjusted rates. So if you'd like to view the results of our information, you can either browse for Alaska InstantAtlas or Informed Alaskans. And lastly, I'd like to acknowledge the support that I received from Art Carpenter, author of Carpenter's Complete Guide to the SAS Natural Language, and also the GeoWise support team. So I'll be providing copies of this presentation as well as supporting documentation of the Access data, SAS files, and others. And I'd be interested in hearing from individuals who would like to apply these procedures to other data surveillance systems. So thank you very much for your patience today.
Thank you very much, Charles, for your presentation. It was an excellent explanation of how you've been using Access Data Manager. And don't forget, if you've got questions for Charles, please use the Q&A box in the bottom right-hand corner of your screen. Okay, so now we're moving on to our next presentation, which is from Jan Weststeyn. As I mentioned earlier, Jan will run a short demonstration of InstantAtlas Server Profiles. Jan's demonstration will focus on how profiles are created, managed, and administered using InstantAtlas Server Platform. Okay, I'll now pass over to you, Jan, to discuss InstantAtlas Server Profiles in greater detail. Over to you.
Excellent. Thank you, Julian. Can I just check that you can hear me okay, Julian, and everybody else can as well?
I can certainly hear you okay. So
here we go. All right. Well, thank you, Julian, and thanks also to Charles for an interesting presentation that highlights the advantage of being able to store large volumes of data in a database. So for those of you who don't know me, I'm Jan. I'm part of the user support team for InstantAtlas. I'm based in Houston, Texas. And my job is to provide support to our North American clients for both our desktop and server-based products. So in the next 15 or 20 minutes, I'm going to show you some examples of our InstantAtlas Server Profiles module, how it works, and I'll also highlight some of the benefits you gain by using this as part of an InstantAtlas Server solution. And then afterwards, I'll show you how you build profiles using an actual InstantAtlas Server administration website on a live demonstration. Okay, so those of you who attended our last webinar with the Arizona Department of Health and Human Services will recall that I spoke in general terms about our InstantAtlas Server product, how it all fits together, and some of the advantages that you gain from using the solution. So for the benefit of those of you who didn't attend last time, I'll give you a very brief synopsis of the main points again. So InstantAtlas Server is a database-driven, off-the-shelf web reporting solution. It can be used to rapidly deploy an entire data-driven website. Now, these websites are known as data observatories, community information systems, or just data query systems. And here are some examples of some clients using our InstantAtlas Server software right now. The CDC's Disability and Health Data System. We have the Vermont Environmental Public Health Tracking Query Tool. And we also have the Pinellas Indicators Community Information System. Those are all live implementations that you can go and look at right now. So while InstantAtlas Server offers a range of different functionality, just very quickly showing you the overview slide here, we have to make clear that there's two primary presentation outputs for your end users, and these are data views and profiles. Okay, so let's start with quickly explaining what data view is. This module allows you to stream in your data that's held in your InstantAtlas Server database or other data warehouse on the fly into our dynamic reports. It also provides accessible tables and a variety of different download options, and you can see an Excel download on the screen here. On the other hand, our Profiles module dynamically delivers collections of data such as text, graphics, charts, and tables, and other content on a per area basis to your end users. So again, some examples on the screen here, including objects like text, a stacked bar chart, some tables, trend charts, and you can see that they're also styled a little bit differently using style sheets. Now, these profiles can be viewed on the screen, as seen here, but there's also a facility to export them to Microsoft Word or into PDF. Okay, so here's a very wordy slide on the advantages of using InstantAtlas Server Profiles. The first benefit is that profiles are designed to be reusable. So the idea is that you build a profile once, and then you can reuse it lots of different times. Now, this applies to both running the profile for, say, different areas, different geographies, but you can also use components within profiles in other profiles. So they're very flexible in that way. Now, this makes them quite a cost-effective alternative solution to maybe existing area profiles that you might already be building using more manual tools and presenting perhaps as PDF or Word documents. Now, another key benefit is that the Profiles module can make use of existing data already stored within your database. Now, whether that's InstantAtlas Server or an existing data warehouse that you have. Now, that means you can load your data once and then make use of it in multiple profiles and in other outputs that the InstantAtlas Server allows you to create. Now, another advantage is obviously that as you update existing data or load new data in, this can automatically become available in profiles, meaning that updating them becomes very quick and easy. A fourth advantage, well, you've already seen this, they can be viewed both on screen in a web browser, accessed via a URL hyperlink, but they can also be downloaded as PDF or Microsoft Word documents. And this gives you the flexibility to deliver different output formats to your end users. So while many people still prefer to receive PDF documents as email attachments, you could just as easily just send them a direct URL link to that same profile. Now, finally, as a web page, interactivity is also key. So web pages allow you to build in hyperlinks to other relevant content, or perhaps to chain related profiles together to provide an interactive journey for your end user through the different presentation outputs that you make available. Perhaps drilling from a summary profile into a more detailed descriptive profile for a given thematic area. And then finally, the sheer flexibility of profiles combined with the ability to make use of web technologies like HTML and JavaScript makes them a very advantageous and open platform on which to further develop dynamically updated and interactive content. So let's actually talk about what a profile is as far as our system is concerned. Well, a profile is delivered to your end users as a web page containing a series of content, and this content can be static, such as maybe textual descriptions of areas or indicators, perhaps logos and graphics, or it can be dynamic data delivered in from the database, such as area-specific content like your measures and statistics. It's built up as a template where you add individual building blocks of content in, and we call these building blocks in our system widgets. So we have a range of different widgets, text, images, tables, various charts, and as I mentioned just on the previous slide, we also allow you to include other web content such as HTML, JavaScript, and so on as well. And this will deliver a set of feature-rich web pages that are both engaging to your users and have the advantage of being dynamically updated from an underlying database. So just to give you an idea of how it works, here is an example of a profile that the end user sees. We've generated this profile for the area of Dales, which is an area in the UK county of Nottinghamshire. And you can see that Dales specific content has been delivered into this profile, both here at the top of the profile, and if we scroll a little bit further down in the table here. Now, if we run this same profile again by just selecting a different area there at the top, we can generate this profile for the area of Sherwood. Now again, the same template has been used, but the data for Sherwood, including the map image, has been dynamically delivered into this profile. Okay, so we can just keep making use of the same template and streaming the data in on the fly. So my final slide is just to give you an overview of how a profile is structured. This is probably most important for those people who are going to end up building profiles themselves. So I've already talked about how a profile acts as a template, and that the data is delivered in on the fly each time the profile is accessed by the user via the website, based upon whatever geography that they've chosen. Now, a profile, probably the best analogy is that it's like a book. It's built up of a series of individual chapters that we call sections. And then each chapter, or as we call it sections, is then populated with individual content pieces or widgets. So my diagram on the screen here, my profile is built up of 3 different sections. And then if I zoom in on my first section, you can see that it's composed of 3 different widgets. And this is the actual content. The first widget is going to be a text widget, second widget a bar chart widget, and the third widget a table widget. Okay, so that concludes my my PowerPoint presentation. But what I'm going to try and do is replicate this structure in my live demonstration. So you can have a look at how it actually works. So if I just close my my PowerPoint down, and if I now share my desktop, just take a little while for you all to be able to see this. You should hopefully now be able to see the administration website of our InstantAtlas Server solution on the screen here. The administration website's used to manage, to load data, to administer, manage, and deliver content to your end users. So there's lots of different functions available in the administration website, including functions to manage your data, create and manage your geography types and themes, build data views, etc., etc. But in this case, we're interested in looking at the profiles module. So I've given myself a little bit of a head start, and I've already created a single profile in this system, a profile called Demographic Overview. And as part of that profile, I've also created a section called Demographic Overview and Benefit Claims. And that section in turn contains a single widget, a bar chart widget that I've created before this webinar started. Okay, so I've kind of put the basic structure in place, and the idea is that we're going to add some content to it while on this webinar. So just to give you an idea of what that looks like right now, if I run my profile for a particular district, you can see that the data for the district of Ashfield is pulled in from the database and presented to you in this bar chart. So we can see that this bar chart shows a particular benefit claimant for it's actually an attendance allowance benefit, and it's broken down over age. Okay, so I've got my bar chart already, and I want to add a bit of text and maybe also a table. Okay, so a very simple example. So to do that, let's go back to the administration website. And here in the widget page, we can start adding new widgets to our system. So let's start by creating a new widget. And I'm going to start by creating a data table. Okay. The first thing that I need to do to this data table widget is add some data to it. So if I, on the right-hand side here, click Add, I then get a list of all the available data in my system. And you can see that if I open up the attendance allowance claimants theme, I'm presented with a series of different indicators from which I can choose to add some of these into my table. Now I might add maybe some of the duration indicators. So how long have some of these claimants been on this particular benefit? And I'll maybe choose some of the time-related ones here. Maybe pick just a few, 4 indicators, and we'll add those to our table for the latest available dates. So they get added into our table. Each of our widgets, the settings can be configured on. So we have some standard settings and some advanced settings. One of the advanced settings is the ability to orientate the table, flip the table around, which I quite like. So I'm going to just set that in there. And then I can give my table a header, attendance allowance claimants by duration. And I could possibly also give it a footer as well. So this data originally came from the Office of National Statistics in the UK in 2011. The final thing is just to give my widget a sensible name, table widget for attendance allowance by duration. And that is my widget created. So I'll just click OK to save. And then what we need to do now is create our second widget, which was this text widget. So we'll create another widget here, click on text, and you can see that the layout of this screen looks very similar to our data table widget we've just worked with. What we're going to try and do with the text is include a combination of both static and dynamic text. And I had sort of an example like this in mind. Rather than me typing it out, I've got it pre-prepared in Notepad here. And the idea is that we've got some static text up here, which really just describes what attendance allowance is and where, what hyperlink you can go to get a little bit more information about it. And then below it, we have a couple of sentences which I've set up in such a way that we're going to substitute the appropriate values for that profile in. So we're going to try and make it read something like, in the area of Broxtowe, a total of X number of people claim attendance allowance, of which 200 are female and 300 are male. That's what we're hoping to achieve. So I'm just going to paste that text onto my clipboard. One of the things I need to do, of course, is pick up my indicator values, the total number of people claiming attendance allowance, and we also need the female and male breakdowns. So I need to add those indicators in. Again, I scroll through my themes. I go to attendance allowance. locate the measures themselves that I'm interested in, which is going to be all claimants, but also the male and female breakdown. We'll add those to our widget. And then if we go to settings, here I have the opportunity to paste my sample text in. And what we're now going to do is just take some of these substitution bits of text away. So in the area of, I want to insert the area name. And then in place of this substitution string, I want to put in the total value for attendance claimants. So I can insert the indicator latest value. Like so. You can see that again, I've taken a bit of a shortcut and already put the female and male figures in there already using this substitution string that starts with the pound symbol. Okay, so all that remains is just to give my text widget a sensible name, attendance allowance overview. Click OK to save. And now I've created my two widgets ready to be put into my profile. So because the profile already exists, all I need to do is just add them to the appropriate section, the appropriate chapter that I want them to appear in. So at the moment, I just have a single one. I'll edit that section. And then this is the section here. The idea is that you click and drag the widgets that you want to appear in this section onto the canvas. Now, attendance allowance, that's really an introductory overview, so I want that to appear before the bar chart. So I'll just move it up one section. So the idea now is that these three widgets appear in this section and they're ready to be viewed by the end user. So I'll click OK to save. I'm really done now, so I'll go back to the user website in my other browser tab. And I'll scroll back to the top and just refresh this profile by running it for a new area. And you can see that my new widgets have appeared. So at the top here, I've got some text, including some hyperlinks to some of the descriptions about what these measures are. And then here we can see that we have in the area of Bassett Law a total of 3,555 people who claim attendance allowance, of which 2,450 are female and 1,105 are male. So that data is being brought in dynamically from the underlying database. If I run it for a different area, you'll see that those figures update as appropriate. And then below we also have our table widget that we've pushed in. So that's just a very quick way of building up a profile. So I guess my next task is just to keep on adding content using the administration website and build this profile up until it's it's got enough data in it and it's of acceptable quality. So where do you get to when you've done quite a lot of work on this? Well, you get to a nice profile like this, and this is a customer example. It's a system called Nottingham Insight, and they use our profiles module to build up a very large range of different profiles. And one of their nice ones is this ward profile. Currently, it's been run for the area of Clifton South, but if we go back to the example I had in my PowerPoint, if I run it for the area of Dales, you can see that it's fetching data from the underlying database and substituting this into this profile template that exists on the screen here. So it takes a couple of seconds to generate all that data out, but then it presents you this profile with data specific to the area of Dales. So you can see a nice map image at the top there, some indicators and measures in the tables here, another table here with a bit of shading, and then we also have a time series chart, a bar chart, and so on and so forth. Okay. Obviously, one of the things I'd point out about this time series chart, you can see there are a lot of different data points here. It's data that's really released every single quarter. So what's really nice about this is that every time a quarterly data update comes out, they just add it into the system, and that data will automatically appear in this chart. There's no need for them to go back and edit this chart and so on and so forth. Once that data is loaded, it just appears in this chart. And then one of the other things I'd quite like to point out is the ability in tables to do conditional formatting. So here they've set up a table and they've shaded certain areas of the table in pink where those particular areas fall in the 10% worst output areas in England. So it's a way of really highlighting particular areas, particular problematic areas in this case in this table. So there's clearly problems of crime, maybe not so many problems relating to housing and so on. Okay, so that was my main demonstration of the profiles module. I've got maybe 1 minute left, so I just very quickly want to show you a variation of our profiles module, which is called advanced profiles. And this is a really nice way for maybe some of your advanced users to create a user-customized profile which features on-the-fly aggregation. Now, what does that mean? Well, so far I've just shown you profiles run for a single area. But using the advanced profile module, I could maybe make a selection of 3 different areas or more. Then choose a profile that I want to run these 3 areas into. You can see that the system's got lots of different profiles and there are lots of different themes, but I'm going to go with the unemployment and worklessness profile. My final step is just to choose what comparison area we wish to appear. So I might just choose to have the national comparison visible alongside my data. And this now, again, generates a profile on the fly by streaming the data out of the database and presenting it to our end users. So you can see that we now have a profile for our 3 different areas that we selected, the districts of Bassetlaw, Mansfield, and Newark and Sherwood. But the system has also worked out what the aggregated figure is as well. So that should be the aggregated figure for these 3 districts in there. And my comparisons also displayed. So again, you can see that all my widgets have been updated from multiple areas. So again, we have tables, charts, and some different time series trend charts down here as well. Okay, so I think that concludes my presentation today. I'll just stop sharing just now. Go back to my presentation, and if anybody has any more questions or would like to explore profiles in a little bit more detail, well, here are our contact details on the screen, and we'd love to tell you a little bit more about them and show you how they can be used to really give you an edge in terms of your area profiling needs. So with that, I'll pass back to Julian to start the Q&A session.
Okay, thanks. Yeah. I've actually just been keeping an eye on the Q&A box, and it doesn't look as though we've got many questions in at the moment. Since I've got you, yeah, and I thought it might be worthwhile. I do have a question for Charles, which I'll come on to, but maybe I can ask you a question first.
Yes.
The question I have is, can I use server profiles for the data warehouse, and how can it add context to my data? I'm just wondering if you can explain that to us.
Yes. Okay. So our server product, it actually comes with its own database as part of it. So if you don't already have an existing data warehouse, you can use our database. But it also has functionality that lets you hook into existing data warehouses as well. So if you already do a lot of this stuff already, you already have your statistics stored somewhere, then InstantAtlas Server can hook into that existing system, pull your data out, and still present it in these profiles that I've shown you. How can you add context? Well, I guess that's what profiles is all about. So you've got ways of adding textual context. You can use some of those the conditional formatting on the tables that I showed you about, that I showed you just now. And there's probably a number of different ways that you could add additional context to that data using our flexible profile platform. I hope that answers your question.
Yes, I think it does. Okay, well, that was great. It was a very useful explanation of server profiles. I wondered if I could bring Charles back in. Again, I'm looking at the Q&A panel, but the question I have for Charles is actually quite useful to see informed Alaskans if you're able to show us Charles, and just explain how it is being used by the Department of Health and Social Services.
Okay.
Can you take us through, Charles?
Okay, one second, I'll just share my desktop. And here, hopefully, are you able to view my Informed Alaskans?
Yes, I can see that, yes.
Okay. Well, what we have with Informed Alaskans is a very comprehensive. One of the things that's easy to show the nature is if we go into our list of our HTML5 maps, and you'll see that for each of our geographic regions, we provide both the results for single maps, double maps, the area profiles, and also the HTML profile. So it's extremely comprehensive. Because we are an agency of limited financial resources, I also have retained the option of displaying flash versions of all of my presentations for those people who either have older computers or are unable to download a newer browser. And then just taking a look at one of our Alaska Public Health Region maps, takes a moment to load, but then you can see in Alaska we have two predominant races. We have both our predominant white, and then we have about 20% Alaska Native. And because we have our own tribal health system, it was very much important to bring in the results for both. So this, unfortunately, rather cluttered. That is that you can see that we have our results for our Alaska Native mean, for our Alaska mean, and then also the mean for whites. And we have superimposed on this our goals. Here's our Healthy People 2020 goals, as well as we have our previously Healthy Alaskans and Healthy People goals from 2010. So the rest of the functionality is what's common to all of the InstantAtlas, is as we move either through our bar charts to the map, you can see that we're overlaying the information. And I just want to bring attention to, for the selection of themes, because I have so many different indicators, it was very important to select themes that would be easy. So I have them organized in demography, quality of life, chronic disease, to allow the users to quickly move down, identify their health indicator, and then drill down into a more reasonable list. So here, and as you can see on each one, I have my results for the statewide total and for whites and Alaska Native breakdowns. So, like I say, so we covered pretty much all of the indicators, and so I've also took the effort, in addition to doing our racial breakdowns, is that we've also done some special reports and where we'll break things down by the presence or absence of disability, federal poverty levels, and also what's very interesting is looking at our senior population within the state. So that's a brief overview. You can get to our website either by Googling Alaska InstantAtlas, or the Informed Alaskans will take you right to our homepage. So,
right, excellent. Okay, well, I can't see any further questions coming in now, and time's marching on. So I think I will bring the webinar to a close. So on behalf of Charles, Jan, and InstantAtlas, I'd like to thank all the attendees to our webinar, and I hope you found it of value and interest. This broadcast will be available in the coming days, and we'll notify you by email when it's available. We'll be running future webinars in 2013, so please, by all means, visit us at InstantAtlas, where our future topics of discussion will be posted. If you'd like to find out more information on InstantAtlas, please contact us directly at marketing@instantatlas.com. So, thank you once again for attending, and we look forward